Hello and welcome to TEC HVAC Airflow Training. My name is Bill Graber. Today's training is brought to you by TEC and our partners Bill Spohn of TruTech Tools and Ed Janowiak of Eastern Heating and Cooling Council. Today in this session, Steve and I are going to be going through the external static pressure method for measuring airflow. If you're looking for information about equipment options for this method, go watch the overview video with Ed and Bill. Okay, so for equipment on this method, what you're going to need is a digital manometer or a magnehelic gauge. The magnehelic has the benefit of no battery. The digital manometers will be more accurate. You've also need a static pressure probe and the tubing, and then you're going to need a drill to drill the holes. In this method, you're going to be measuring the pressure change across the equipment supplied by that OEM or original equipment manufacturer. And so whether it's a furnace or an air handler, that might mean you're drilling near different pieces of the system, but it's always the entrance and exit to the equipment being supplied by that OEM that you're going to be measuring. So for example, on an air handler, that might be right before the indoor coil and right at the exit or right after the blower. But on a furnace, it might be right after the filter and right before the coil. Sometimes that can be a little confusing. But remember, you're comparing a pressure change to get the flow, and it's the entrance and exit of that equipment supplied by that OEM. We're now going to go through the step-by-step process. You can find this information at hvacairflow.com as well. And the first two steps of this process involve pulling the chart for the equipment or the table for the equipment that you're working on, and making a note of the speed settings. Now, for our video demonstration, you're going to see Steve in the TEC Training Center working on a Goodman furnace, which we have installed. So let's take a look at that now. Here's Steve taking a look at the furnace, and he's taking the front cover off, which is often where this information is located. On the left is the Goodman model number, and on the right is the fan connection information. Steve will use that information when he's looking at the board where the blower fan is connected to determine what the settings are. You can see that cooling is on black, heat is on orange, and both blue and red are parked. Okay, so you saw Steve got the model number and noted the blower speed settings. And with that information, using Google or the manual, can make sure that we have the right table or chart where we're going to convert that external static pressure we're about to read in inches of H2O or inches water column so that we can look up the right flow reading. With that in hand, it's reasonable to go to the next steps. If you can't find that information for some reason, you really should move on to a different method because you need that exact table to make sure that you're converting the pressure change to flow correctly. Once you've done that, you want to ensure your system is set to the right speed setting and is in the right condition. So if you're trying to measure a high cooling speed, make sure that the system is running at that speed. You also want to make a note of, in the table, what does the manufacturer state for specific conditions that should be met. On this furnace in the TEC Training Center, pulled that fan table, and at the bottom it says the airflow data indicated is for a 230 volt without the air filter in place. They also provide some adjustment factors depending on what orientation you have to the table values. For this air handler, or just one example of an air handler, you're going to want to typically make sure that you match coil conditions. So Ed Janowiak talks about this quite a bit. Most manufacturers will specify that the coil would be in a wet condition. Others will provide dry or both. Go to the next step, which is to be drilling holes in the system. So in the TEC Training Center, we have a Goodman furnace, and right before it is a filter slot, and right after it is an indoor coil. So Steve will be looking for a spot to measure just inside that Goodman cabinet. Here he is looking for the entrance. You can see the filter slot. He's taken that cover off and knows this is a safe spot to drill for the entrance measurement. And then he will speak directly about the exit measurement. We have an end coil, and he's going to talk about why to measure into the furnace cabinet and not the coil compartment. This audio is a little rough.
Okay, when drilling this, we need to be careful to avoid the refrigerant lines and the drain pan. So I'm going to put down my drill because you can see that the drain pan comes really close to the edges. And if this were an A coil, this drain pan would be up against the side, and all the way around the side would be very near the drain pan. So we don't want to drill into this cabinet if we can drill into the furnace cabinet instead.
So here Steve is showing you with that coil off so that you can see at the top of this furnace cabinet, there's quite a bit of space, and we're sure not to damage any part of the system. You always want to check to make sure, but typically this is going to be a safer spot. Now Steve is drilling right where that coil would mount, and here's a side view so that you can see he's right at the top. The other benefit of this location is that you can insert your static pressure probe up and over the top of the insulation provided by the OEM. Here's another view of that. Okay, with the ports in place, now we're ready to make the measurements. So let's take a look at Steve doing that. Here he is inserting the static pressure probe on the entrance, and then he's hooking it up to the DG8. You could already have the tubing connected to your manometer as well. A reading of about negative 0.36. Now we move over to the exit, or just before the coil. And in this case, we get about 0.2 inches. Okay, with those measurements made, we're now ready to go back to that OEM fan table or fan chart and convert our readings into flow. So let's talk a little bit about what we saw. Steve made two measurements on the furnace. At the exit, he measured just under 0.2 inches, and at the entrance, he measured just about negative 0.36. Remember, we're always going to take the total difference there to get the pressure change across that OEM equipment. So in this case, when we subtract those two or add the two values together, we get about 0.56 inches of H2O, or inches water column. So now we're ready to go back to the table we pulled for the Goodman furnace that we have, and we'll convert it. So remember earlier we had the model number and the speed setting defined. It was medium low, and we just said that we had a measurement of 0.56 inches of water column, or inches H2O. So in the table there's both a 0.5 column and a 0.6. So making a note, at 0.5 it would be 926, and at 0.6 it's 861. Now if we're just estimating flow, we can look at those two and say somewhere between 860 and 925. So 0.56 is about in the middle, so it's about 890. Now there is a method, don't want to imply that you can't get to a more precise answer from the table. When we do the exact math through interpolation, we get to 887. Okay, so what you can see is this method, there's some really good benefits to this method. First of all, it's very cost effective. You don't need to buy a lot of equipment. Much of it you will already have. You don't need a highly accurate manometer to do this specific test. And it's pretty quick to do once you get comfortable with drilling the ports. Another benefit is it's recognized by ANSI, ACA, ResNet 310 for grading new installations. The cons are you're using that OEM manufacturer's table to convert pressure to flow. And so if you're not matching the exact conditions that were present when the OEM developed that table, then you have some uncertainty. It can lead to poor measurements and more limited confidence in your measurements. And so while it's recognized for grading new installations, if you're going into an existing installation and trying to verify the flow as part of troubleshooting or confirming equipment, then you're going to have less confidence in these readings, because a dirty blower or a dirty coil can really impact the readings you're going to get. Okay, now that you've measured flow, what's the next step? And that will depend on what situation you're in and why you were measuring flow. In a new installation, perhaps you're grading your install either by your company policy, or maybe it's per ACA ResNet 310 for a HERS rating. In that case, we're going to be taking that measured flow and comparing it to the design flow. In an existing installation where we're troubleshooting, it's a little bit more involved, so let's talk about that for a minute. In these cases, perhaps we're invited in because the homeowner or occupant is having a comfort or performance issue, like some rooms are hot, some rooms are cold, or maybe there's humidity or moisture condensation issues. In that case, what we want to do is propose a solution that's really going to solve the problem, and that means that measuring airflow alone probably won't give us an indication of what the root cause is. We need to make some other measurements before we propose our solution. Oftentimes, in addition to airflow, on the air side, what we want is to measure a series of air pressures. You know, the supply, the return, and then pressure drops involved across the coil and the filter. That will allow us to look at the external static pressure as well as these individual pressures and airflow. And by having all that information, now we can start to diagnose what is causing the issue and what we should be proposing. And that's what the digital TrueFlow solution tries to support. You can certainly do these measurements without this solution. This solution will help you make those measurements in a consistent way, make accurate measurements, and then gives you a report that summarizes all of your measurements, but also helps give you a start on the diagnosis of what you'll see. In this example, there was a lower flow reading and a higher return duct pressure, and based on the combination, it's suggesting that looks like you have some return ducts either blocked or undersized, and that would be a good thing to do to increase the airflow and address perhaps this comfort issue. The TEC Digital TrueFlow solution also is on the roadmap to work with MeasureQuick. Hope you enjoyed this session on airflow measurement. If you're looking for more information, visit hvacAirflow.com, and we look forward to seeing you again soon.